Hello, juniors! For this lesson, we will learn linear motion. Objects move in motion, right? Those objects move in one dimension, two dimensions, and three dimensions. Today, we are going to study the motion of an object in one dimension, and that is linear motion. Linear motion can also be called motion in a straight line. Let's begin from the introduction of position, displacement, velocity, and acceleration of an object. Are you ready? Let's start with position. The position of an object along a straight line can be uniquely identified by its distance from the origin. What does that mean? It means that the object only moves in one coordinate in the Cartesian plane, which may go to the right or to the left of the zero. The position of an object is relative to the reference frames. But what is a reference frame? A reference frame is an arbitrary set of axes from which the position and motion of an object are described. It means that it is where we base the motion of an object. Take, for example, a rocket to be launched to the outer space. Since the final destination of the rocket is in outer space, we can use the Earth as our reference frame. And from there, we can now calculate the position of the rocket with respect to Earth. But not all reference frames are stationary in a linear motion. Sometimes, there are moving reference frames that we use in getting the position of an object in motion. Like when we measure the position of a person in a boat traveling to another island. We don't have to use the Earth as a reference frame to get the position of the person in the boat. We can also use the boat as a reference frame to get the position of the person. But what if, after getting to that position, the person move again to another position? That is where the displacement comes in. The displacement of an object is the same as the distance traveled by an object in a particular direction. For example, a person is standing in front of a door. He decided to move to the table beside the door. The person now has an initial position which is in front of the door and a final position which is beside the table. The change in position is the displacement. The SI unit for the displacement is meter. Mathematically, displacement is given by delta x to final position minus initial position. Did you know that the fastest human ever to ride a bicycle is a woman? Yes, you heard it right. She is no other than Denise Mueller-Kornick. She clipped her bike to the back of a dragster, driven by racing driver Shea Holbrook. She had to be towed for the first section of the run because the gearing on her bike was so high that pedaling from a standing start wouldn't be possible. At around 100 meters per hour or 160 kilometers per hour, she unclipped from the pace car and started accelerating. And from that, everything was history as she achieved 183.931 meters per hour or 296.009 kilometers per hour. She was instructed to not go over 175 meters per hour as it was very risky. But she took the risk and set the world record as the fastest human ever to ride a bicycle. Now going back to the topic, let us talk about the velocity of an object. The rate of change of displacement of an object in a particular direction is its velocity. The velocity of an object is measured through the displacement between 2 points all over the elapsed time between the 2 points. We know that displacement between 2 points, right? But what about the elapsed time? Well, the elapsed time between 2 points is just the time taken to travel between 2 points. Also, do note that the average velocity is a vector, which means that it can either be positive or negative. This usually depends on the position of the initial position and final position. This means that if the object moved to the right, the average velocity is positive. An object moving to the left has negative average velocity. Lastly, let us talk about the acceleration of an object in a linear motion. In physics, acceleration of an object is the rate at which the velocity of a body changes with time. It is a vector quantity with both magnitude and direction. Note that acceleration of an object is a vector that points in the same direction as the change of its velocity, but it may not always follow the direction of the object's motion. What does this mean? It means that acceleration does not depend on the object's motion because acceleration may be in opposite direction of its motion. An object may slow down, which means that the object is decelerating, and decelerating is the opposite of accelerating. The SI unit of acceleration is meter per second squared. Before I end this video, let us summarize everything. In this lesson, you learned about linear motion. You also learned about an object's position, its displacement, velocity, and acceleration when in linear motion. Did you enjoy this topic? I hope you certainly did. So what's your takeaway?